Hello everyone, I am Dr. Subhasish Saha, Assistant Professor of Physics, Department of Humanities and Science, MLR Institute of Technology, Hyderabad. So today I will discuss about the basic introductory idea or how to evolution of the quantum mechanics. So first of all, what is quantum mechanics? So before going to that, I am just giving some overview of that. So introduction in quantum physics. Next is the origin or the evolution of quantum physics. These are the brief overview today's I will present through this lecture. So first come to the introduction part. What is quantum physics or quantum mechanics? So quantum physics or quantum mechanics is a branch of physics that deals with the behavior of matter and energy at a smallest scale, as such as atomic and subatomic particles like electrons, photons, quarks, which do not allow the laws of classical physics that govern the larger objects. So this is actually gives some idea about how to deal with the matter particles or waves, and as well as the energy in microscopic states or in microscopic scale rather than in macroscopic scale. So these are the basics idea how to deal with the particles in microscopic scales. So this is some introductory idea about this quantum physics. Now come to the next point. What is the origin or evolution of the quantum physics? So this is actually the origin of the quantum physics is when actually some of the problems which are not able to solve in classically, that is including Newtonian mechanics, as well as Maxwell electromagnetisms, which could not be explained. So that was started in the late 19th century and early 20th centuries. So these are the basics idea from where actually quantum mechanics started. So I will go some sequential order in year wise, where actually we actually see the how to evolution is happening in the quantum physics. First of all, it's come to the first explanation is come for the black body radiations. In 1990, so the black body radiations, what actually happened? So in classically when actually scientists try to predict the energy spectrum of the black body radiations, so they are unable to explain, which is not matched with the experimental data or results. Actually what happened classically, they are predicted the energy radiated by a black body which is actually take care at high frequency in a continuous manner in over the entire region from 0 to infinity. But it makes a problems. Result is entirely different from the experimental results. That's why these problems were solved by Max Planck, who proposed that the energy is not emitted in a continuous manner, rather than it comes out in a discrete manner in a energy packet or quanta of energy. It is called quanta of energy, which is also called as a photon. So he was first introduced about the energy quantizations. How the energy is quantized. Energy quantization means energy is integer multiplication with h nu, where h nu is the energy of a photon. Okay, so this is some idea he gave, that rather than in a continuous manner of the emission of energy, if you consider energy is a certain discrete manner or a quanta of energy is called as a wave packet, so then it will give some idea to explain the black body radiation. So it is also gives you the quantization of energy or energy quantizations. Next explanation, next idea is come out little later in 1905. So that is your photoelectric effect. So what actually Einstein has first proposed this idea, which is actually take care of the Planck's energy quantization idea or Planck's black body radiations, what he explained. That idea is also taken consider to explain the photoelectric effect. What is photoelectric effect? When the light is incident on a metal surface, so that time electrons will comes out from the metal surface. But classical wave theory of light are unable to explain those phenomena, why actually the only certain range of frequencies are able to allow to eject the electrons. So in that case, Einstein's proposed that the light is consist of some particles are called photon, which is carrying out some certain range of energy, that is E equals to h nu, or n h nu is a integer multiplication of h nu. So it is also considered as a discrete certain range of energies. Actually these also take care of the similar things like Planck's, whatever he explained the quantization of energy. So these actually take care of these things, and only that case the photoelectric effect will be able to explain what will happen when the light is incident on the metal surface. If the energy of that incident particles or photon is greater than the work function of that metal surface, then only electrons will eject. So, and certain range of frequencies are take care of that things. Okay, this is the another idea about the photoelectric effect. Next evolutions is come out the atomic structure and Bohr models in 1913. So what is actually happened? So Niels Bohr and Sommerfeld give some quantum idea how to model the atomic structure. So Bohr first proposed that the electrons evolves around the nucleus in some specific and quantized energy levels, and like it is quite similar to the how the planets are evolved around the sun in a certain orbits. So similar structure actually he proposed in quantum mechanics to determine the atomic structure. So these are some kind of model structure. In that case, electrons can jump from one energy level to another energy level by absorbing or emitting photons. So these Bohr models actually introduce very successfully the stability, are able to explain successfully the stability of the atoms. So these are the next topics is your wave particle duality. So this is also come out in 1920, 40 and 26. What will happen actually? So in these cases, it was considered the particles like electrons or photons, both are these particles behaves like both particle nature as well as the wave nature. So first of all, we already have mentioned that the Planck's quantum theory very successfully explained the black body radiations, photoelectric effect, or Compton effects, in which case radiation interact with the matters in the form of photon. Okay, which is actually take care, it behaves like a particle nature. Okay. On the other hand, Young double slit experiments very correctly explain the interference or diffraction phenomena. To explain this phenomena, it was considered that the two particles can occupy the same position at the same instant of time. So this is only possible when this particle is treated as a wave. Okay, but both of the properties like wave properties as well as particle properties are not able to explain from the same experiment, cannot be observed. So this is introduced the concept of complementary. So this is further another examples of the wave particle duality comes like de Broglie in 1924. De Broglie hypothesis proposed that the particles such as electrons exhibits their wave nature properties, and this was experimentally confirmed by the Deviation-Jammer experiment in 1927, where actually he showed that the diffraction of electrons demonstrating their wave nature, like it is introduced the matter wave nature. So this is experimentally proved. Later on, Schrödinger in 1926 also formulated the Schrödinger equations, which describes how the evolution of the wave functions, like spatial evolution of the wave function over time. It was explained by these Schrödinger equations, and the square of the wave functions take care of the probability distribution of the particles in positions, momentum, and other observable forms. Okay, so this is another example. So we come the Heisenberg uncertainty principle. It was proposed by Heisenberg in 1925. Actually, what is proposed according to Heisenberg uncertainty principles state that certain pair of physical properties like positions, momentums Okay, those are canonically conjugates, means those are non-communicate with each others. So if we take care of these properties, those are canonically conjugate certain pairs. The uncertainty product of this position and momentums gives some constant value, that is your h cut by 2. So that is introduced by the Heisenberg uncertainty principle. So what is delta x and delta p? Those are uncertain position and momentum. That product will give you some constant value, that is h cut by 2. So h cut is a reduced Planck constant. Next is your Dirac's quantum field theory and Fermi Dirac statistics is proposed in 1928, where actually Dirac develops quantum field theory and introduced Dirac's equations, which actually combination of quantum mechanics as well as special theory of relativity and predict the existence of antimatter. At the same time, also Fermi Dirac statistics was developed to describe the particles called fermions, such as electrons, which obey the Pauli exclusion principle. So these are some evolutions of the quantum mechanics or quantum physics slowly. So the overall conclusion is that the quantum mechanics originated to solve some problems which are not we are able to solve classically or not able to explain classically, such as black body radiations, photoelectric effect, atomic spectra. To solve those problems, actually the quantum mechanics was introduced. On the over time, actually it's developed into a comprehensive theory describing the behavior of particles at microscopic scales, fundamentally altering our understanding of reality. So these are some the idea actually how the quantum mechanics, from where the quantum mechanics has started, what is the origin. So how the evolution is going on, on which perspective the scientists face the problems, and how they actually propose some models or some idea to overcome that problems which are unable to solve classically. So these are some theories and models are proposed, and that is some year wise actually that is a progress or evolution was happened. So this is some peripheral idea about the starting of our quantum mechanics or quantum physics. So I hope this lecture will give you a lot of qualitative information about the starting of the quantum physics. So in the next video I will come up with the in brief discussions about the black body radiations, how is the your energy spectrums as a function of wavelength or and temperature. These things I will come late in next video. Okay, thank you.